Welcome to the Math Record. Today we'll be learning how to solve polynomial equations and inequalities. This video will cover part 5 and probably the final part in chapter 2 of our Precalculus class. Okay, let's begin with solving polynomial equations. To solve polynomial equations, both equations would just be asking to look for its x-intercepts. As explained in our previous video in part 4 in chapter 2, there are multiple ways to locate the roots of a polynomial, but in this video we'll only be using the rational zeros theorem and factoring. We won't be using calculators because we will be doing this by hand. In general, to solve a polynomial equation, you first use the rational zeros theorem to find the possible zeros, and then you test the points using the remainder theorem and factor. So let's take, for example, our equation f of x is equal to x to the power of 4 plus 4x to the power of 3 minus x squared plus 16x and minus 20. So we have this, and minus 20. So first we use the rational zeros theorem, which tells us that the factors of 20 negative 20 over the factors of 1. So factors of 1 is just 1, so what we only need to look for is the factors of negative 20. So let's say negative 20, the only possible factors are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20, which I think is all of it. Yes. So, as I said before, you want to use the smallest possible integers and then work your way up. So we're going to use the remainder theorem that says that if f of a is equal to 0, which a is like some kind of number, then x minus a has to be a factor of f of x. That's what it says. So I'm gonna erase this. So let's plug in like 1 first. So that's 1, that's 5, that's 1 plus 4, that's 5, 4, and 20. Yeah, so x minus 1 works. So let's factor x minus 1 out of the equation. So x minus 1 as goes to x cubed because that makes x to a 4, so that's minus x cubed. So you have to add a 5. So that's minus x. So that's plus 5 x cubed, and that's minus x cubed, so that's 4x cubed. That's minus 5x squared. So we need to add a 4 plus 4x. And then this would be plus 4. This would be minus 4. So you have to 4x squared. So this would be minus 4x. So you had to add a 20, which makes sense because that makes negative 20. So this is the equivalent as this. So we're gonna find out when f of x is equal to 0. Basically the process. So we want to factor this entire thing out. So we still have a cubic. So just plug. Let's just start plugging in more digits. So since we have plus 1 is out, let's put in negative 1. So that's negative. That's negative 1. That's 4. That's 1. That's 20. Okay, so 1's not gonna work. We could actually just start using the calculator for these. As I said before, we're not supposed to use the calculator to solve for the zeros, but you could use it just to do the random math because it'll be quicker. So 2 cubed plus 5 times 2 squared plus 4 times 2 plus 20. Nope, not gonna work. So we have, now let's try negative 2. So negative 2 to the power of 3 plus 5 times negative 2 to the power of 3. Negative 5 times power of 2 plus 4 times negative 2 plus 20. That is also positive. That's positive 24, so that's not going to work. We're going to use 4. So 4 to the power of 3 plus 5 times 4 to the power 2 plus 4 times 4 plus 20. Okay, it's not going to be any of the positives. For sure, it's not going to be any of the positive because all these are positives. So technically, if you're going to put more positive, it's just going to be positive, I think. Probably. So it's not going to be positive 4, so let's just try like negative 5. So negative 5 to the positive, negative 5 to the power 3, 5 times, plus 5 times negative 25, 25, plus, negative 20 plus 20 is 0. Okay, so negative 5 is also a factor. So, let's write x minus 1 first. And now we have, x minus 5. X is negative 5, so this is a plus 5. So this one's x cubed, because that makes x cubed. X squared, because that makes x cubed. So that's 5x squared. We got that out, so we're not going to use a x on the next one. We're going to use a constant. So we need a 20, so this one's probably just 4. So that's 5x squared, 4x, 5x squared, and that's 20. So that works. So this all factors out. I know this is not going to factor out because this is a quadratic, like this, is upside the up on top of the x-axis, so it's not going to have any actual zeros. But if you want to factor it out, it will be x minus 1, x plus 5, and if you ever see plus, like just a constant, what you do is that you use I. So it's x plus 2i, and x minus 2i. I is equal to square root negative 1. So what you really want to do with this, if you've never learned how to do I, is that a simple method is just to use a quadratic formula, right? So you have x squared plus 4. So it's negative b. B is, there's no b, so there's no x term, so there's 0. Negative b plus or minus square root. B squared is 0 minus 4 times a, which is 1, times c, which is also 4, all over 2a. So 2 times 1. Okay, so that's a quadratic formula. So this would be 0, so square root, that makes negative 16. So this is negative, square root negative 16 all over 2. You could factor out square root negative 1 times square root 16, because that's a radical property over 2, right? In precalculus, I is equal to square root negative 1. So if, and we forgot, and there's the plus or minus on the outside, plus or minus, which is still a thing. So now we have plus or minus, I'm running out of space, sorry about that. So we have plus or minus square root negative 1, which is SI, because we just substitute it in. And square root 14 is just 4. So we just multiply by 4, divide by 2. So that's equal to plus or minus 2i, right? So the factor is 2i and negative 2i, which is the same thing right here, which just put it in. And that's how I know. So that's basically how you do it. You just use the quadratic formula if you want to look for like any roots. If it has a negative square root, just take out the negative and substitute it with an I, and just like get the I factors, I guess. So basically, this is not part of the question, but let's say you have 5 plus or minus like square root negative 17 over like 2. Then the answer is just 5. Distribute out the negative 1. So it's negative 1, square root negative 1 times square root 17. So square root negative 1 is just I. So it'll just be plus or minus square root 17. Actually, put I in front. I square root 17 over 2. So those are the roots. And then you can just plug it in, and they have to subtract each other out. So, So this answer would be 2i, and this would be negative 2i. But these are imaginary roots. It's not going to be on the in the normal plane that you're ever going to put. They're going to be in a different plane, but you're not going to be learning this right now. We're going to do this in like a future video in the precalculus class. So right now, you just need to know that these things exist if they ever ask for the zeros. So the zeros are equal to x is equal to 1, negative 5, negative 2i, and 2i. So those are our zeros. So so that's how you solve a for the x-intercepts for a polynomial equation. So let's say instead of saying that this thing is equal to 0, right? Let's say that this thing, let me erase this part first. This thing is still f of x, where I just need room. So, and let's say this thing has to be greater than 0, right? So in inequality. So what you're gonna have to do is that you have to find when this polynomial is greater than positive. So let's say this is how you're gonna do a polynomial inequality. So you're gonna have to factor this out. But what you do is that you're gonna ignore this part because we're not gonna we don't want to have the imaginary roots because there's no imaginary roots in in our inequality because it doesn't work. So you don't have to do this step in the imaginary inequalities. But in like if you're solving for zeros and they're asking for real zeros, you also don't need to do that step. The only reason you ever do this step is that you need to get the complex zeros. So if that question as you ever ask for complex zeros, you have to put the imaginary roots, which is 2i and negative 2i for this example. If you ask for real roots, just put 1 and negative 5. But for inequalities, you never have to do it basically. So what this tells you is that this thing will always you're gonna have to factor this out. Like you do the exact same process for the polynomial equation and you factor it out, and then you're gonna make a sign chart basically. So you're gonna list out the zeros. So you're gonna have a 1 here, and you're gonna have a negative 5 here. There's no roots here, so you're gonna think about this in a number line, right? So you're gonna have like a really big negative, a really big positive. This is negative 5, so make a line here. That's negative 5. And you make a line here, which is 1. So you're gonna have to think about how the graph looks in. You're gonna have to plug in a point for each of the graphs. So since this is negative 5, right? Let's just choose something like negative 6 because it's negative infinity to negative 5. So let's choose something like negative 6. So we plug in negative 6 into our equation. We get negative 7 right here. For this one, this will be negative, and this part will always be positive. This part, a quadratic is always positive right here. This one is always positive. So a negative times a positive is positive. So what it tells us that using a sign chart that this portion is positive. So this is above the x-axis. And then we have negative 5 and 1. So let's just, if it's a negative and a positive, I usually just choose 0, x equals 0. So let's put 0 in here. That's negative 1, that's 5, so that's a negative, and that's always positive. So this would be negative. And a 1 to positive. So let's just choose something like 2. So 2, that's positive, positive, positive. So that's just a big positive. So in a graph, it would just look something like we have a negative 5 and we have a 1. And it's going to be a quadratic function. So it's going to be, as it goes negative, it's going to go positive. So we're going to, so it's going to be something like this. So it's going to be from 0 to negative 5. So that's negative 5 here. So it's going to be positive all the time. And then from negative 5 to like 0 is going to be, negative 5 to 1 is going to be negative. So it's going to be below the graph. Since it looks something like a W, a quadratic looks something like a W. So it's going to be something like this. And then, but you can also just plug this in. So if you plug in 0 here, that's 0, 0, 0, 0, and that's negative 20, which makes sense. And then you put in from 1 to positive, it's going to be also positive as it goes to like a really big positive. So it's going to look something like this. So when it's so this graph is a positive at this portion right here, which is already set by the sign chart because you don't really have to make the picture. But I'm just trying to show you. So from the answer would be, how you write this in notation is that you put negative infinity. Infinity represents a really big number. So that's why you write a negative infinity to negative 5 and union and 1 to infinity. Negative infinity is just a really big negative, and infinity is just a really big positive. So, and that's how you do it in inequality. You use union. You always use union. You never use intersection. You always use this U. That's how you, if you want to learn, how do you learn union versus intersection and you want to remember the symbol? Union starts with a U, so it's just union. Intersection, N, intersection. I'm not gonna spell the entire thing because I don't have room, but that's basically how you remember. That's how I remember it. Union with the U, intersection kind of looks like an N, so intersection. So that's how I remember it. This is only for like when it's greater than or equal to. I mean greater than or less than. When it's like greater than or it's greater than or equal to or less than or equal to, you're gonna have to use these brackets. So what these tells you is basically let's say this is greater than or equal to 0, right? So there is then you have to write the answer as -5 bracket union bracket 1 comma infinity. When it's greater than or equal to, basically. Because what these kind of like curve brackets are, they say that the numbers at the end does not count. For infinities, it's always gonna be a curve. It's always gonna be a curve, okay? So but for like zeros, if it's just a greater than or less than, you put also these curvy brackets. If it's greater than or equal to, you put these like actual brackets, the ones that are rectangular. So this means that the number is included in the solution set. So -5 is a solution if you put this, like this rectangular bracket. But if you put like this bracket, not this one, then you're saying -5 is not part of the solution, which is not true because if you put -5 here, that equals equal to 0, and 0 is greater than or equal to 0. So so you have to put a bracket. So that's the difference. So that's basically for polynomial inequalities. You just need to learn your note. So what you need to do is that you do the exact same thing for polynomial equations. Solve it using the rational zeros theorem. Solve the possible for the rational zeros theorem. Plug those values in to use the remainder theorem to find out when it's equal to 0, and then you factor it out, and then you kind of solve. So you solve for you put 1 and -1 and make a number line, and you do the sign charts by just plugging a number between these in. So you can plug in -6, -7, -8. It just has to be below -5. And you have to plug in a number between -5 and 1. So you could plug in like -4, -3, -2, -1, 0. Or and then for 1 to plus, you have to have something higher than 1. So like 2, 3, 4, 2.5, like it doesn't matter. But I usually choose integers because it's easier. So you make a sign chart. You really don't have to make this picture. So once you have this sign chart, you plug in these values and you get positive -0, and you find out which one is like part of the solution set, and you just write it down. If it's less than or equal to, put brackets. If it's not less than or equal to, like it's just less than or greater than. I mean less than or equal to or greater than or equal to, then you put these rectangular brackets. If it's not less than or equal to or greater than or equal to, then you use the curve brackets. I don't know what the specific names are. And for infinities, you always use brackets. You always use brackets. Anyways, that is all for this video. Thanks for watching, and I'll see you at the next math record.